Hello everyone, I'm Varun.
Hi, I'm Deepan.
We are graduate students at University at Buffalo, and we are here to present our final project for EE 500 Embedded Systems course. As a final project, we designed an air quality system using LPC 1768 microcontroller, and we utilized temperature sensor LM35D by Texas Instruments and humidity sensor HIH4030 by Honeywell.
Air quality sensor will act as a platform to manage and control indoor adverse conditions. The system consists of two sensors, humidity and temperature. They are using ADC converter, which is located on board, and it transfers the analog value and converts into a digital format, which is further sent to a host PC using an Ethernet protocol.
Now we'll demonstrate our system setup. Our setup consists of three main components. One is the sensor board, second MBEST LPC 1768 microcontroller, and a Windows-based whole PC. On our sensor board, we have three main components. One is the voltage regulator, which is responsible for providing a 5 volt or a 3.3 volt based on our needs. We are currently providing a 9 volt DC supply to it through a wall adapter, and we are getting a 5 volt output out of it. Next, we have a temperature sensor LM35D, whose output voltage is linearly proportional to the degree Celsius temperature. It's a 3-pin sensor. We have pin 1 connected to 5 volt, we have pin 3 going to the ground, and we have pin 2 going onto the pin 23 on port 0 on board. We configured this pin 23 to be analog to digital input port pin 0. Similarly, we have a humidity sensor HIH4030 by Honeywell, whose output voltage is linearly proportional to the relative humidity. Similarly, we have a 5 volt DC supply, and we have one pin going to the ground, and the output is connected to the port port 2, pin 2 or port 0, which we configured as analog to digital pin 7.
Now, as Varun mentioned, these two are the analog inputs, the green wire and the blue wire, and the white wire you see is the ground. It's a common ground between the board and the sensor board. This both analog inputs on the board are converted with the 12-bit resolution rate, which is further averaged out and passed into the formula based on the data sheet to get a relative humidity and a temperature and respective units. As you see, the humidity is in percentage and the temperature is in Celsius and Fahrenheit. Right now, the current humidity of this room is around 26%, and the temperature is around 21, which is around like 70 degrees Celsius, 70 degree Fahrenheit. Sorry. Now, based on the threshold limit we set, I will demonstrate what happens if the actual value exceeds or is equal to the set point. Now I'm going to blow air on the sensor, which will increase the humidity As you see, you will see warning, and the LEDs are also blinking, which tells the user that there is a warning condition at present on the board. This board also consists of the Ethernet controller, which enables TCP/IP connections between two devices. In this project, this microcontroller acts as a web server, which is hosting a website. This website consists of the humidity sensor and temperature sensor readings. It also has a data logger. Now this portion here, it updates every time a new value comes in. That means it gives a functionality that to log a data, the important data, only like by pressing the button here, the last save last sensor data. This is only a user-driven event because some of the data are important and some are not. So every time a user sees an important data coming, he can create a log by clicking here, and this will be logged into this text box. Now, this text, you can generate multiple files and copy that to a Word or Notepad, making a text file for the records. So the air quality system can be a really useful tool and can be used in health industry, or can also be used in regular indoor, to measure indoor air conditions. I hope you enjoyed our demonstration. So this is basically what we have, the live values coming from the sensors to the board and hosting it on the web server.